pursuing my Masters in Technology from International Institute of Professional Studies DMV in Law. Today, I am here to present my data science assignment that includes the topic Naive Bayes classification.
So, first of all, we understand what is the naive Bayes. Naive Bayes is one of the very simple and powerful algorithm for classification based on Bayes theorem with an assumption of independence among the predictors. The naive Bayes classification assumes that the presence of a feature in a class is not related to any other feature. Naive Bayes is a classification algorithm for binary and multi-class classification problems. Now, we see the naive Bayes theorem using Python. So, first of all, we import the libraries like import math, import random, import CSV. Then we have a function called encode class. The categorical class names are changed to the numeric data. Then we split the data. Then we have the splitting function for splitting the data, in which we have the parameters named my data in the ratio. Initially, test set will have all the data set. Then we have index generated randomly from range 0 to length of the data set. From data set, pop data rows and put it in train. Then we return the value train and test. Then group the data rows under each class yes or no in dictionary, example dictionary yes and dictionary no. For that we have a function called group under class in which the parameter is my data. We return the value of the dictionary from the function. Then we calculate the mean. For that we have a function named mean of numbers in which we return the sum of numbers divided by float of length of numbers. Then we calculating standard deviation. For that we have a function called std/dev in which the parameter are numbers, in which we return the math square root of variance. Now we have another function called mean and standard deviation in which we calculate the mean and standard deviation. Here mean of first attribute and mean of second attribute are given as a plus m plus x and b plus m plus y divided by 3. Then we delete the summaries of last class. Then we return the info. Next we find mean and standard deviation under each class. For that we have a function named mean and standard deviation for class in which the parameter is my data. Then we have to calculate the Gaussian probability density function, for which we have a function called calculate Gaussian probability in which the parameters are x, mean and standard deviation. Then we calculate the class probabilities. For that we have a function named calculate class probabilities in which the parameters are info and test. We return the probability from that function. Then we make prediction higher probability in the prediction. For that we have a function named predict in which the parameters are info and test, in which we make prediction about the highest probability in the prediction. Then we have a function called get predictions in which we return prediction for a set of examples. Then we have a function called accuracy rate in which we return the accurate score. Then we have a driver code in which the file name is the file data.csv. Here is the file we save on the desktop for file name.csv. Then we have load the file and store it in my data list. Then we have the split ratio is equals to 0.7 and 70% of data is training data and 30% is set data using for testing. Then we print the total number of example. Out of this training examples are and test examples are. Then we prepare the model like info is equals to mean and standard deviation for class function in which we pass the train data. Then we test the models like from the function get predictions and accuracy rate. Then we print the accuracy of your model. Now we run the program. Here is our output. The total number of examples are 768. Out of this, training examples are 537. The test examples are 231 and the accuracy of the model is that. Thank you.